Let's do one thing. Now let's go into our studio and see how to do a k-means clustering and also a hierarchical clustering. So what we will do is to start with, I will share with you the data set which we will use. It's there in the CSV file, so which I opened as a spreadsheet. So you can see that this is the data of uh, 20 customers who go to grocery store and buy over a period of let's say 1 month, and this is the data that the customer one bought during the month: 5 items from bakery, 6 items from stationery, 3 items from the frozen section, 2 items from grocery section, 1 item from dairy section, and 12 items from vegetable section. Similarly, customer 12 bought 10 items from vegetable section, 1 item from dairy, 3 items from grocery, 3 items from frozen, 12 items from stationery, and 5 items from bakery section. So now essentially each customer have their different requirements, and they are recording what the customer is buying. The supermarket is recording what the customer is buying, and so for these 20 customers, they wanted to group them, and they may want to do something. So first, segment the customers into different types of customers. So now what we will do is I'm stopping to share this data. So I will share our studio. So to start with, what I need to do is I need to set the working directory, because I have to read that CSV file uh, into the studio or environment. I have, okay, I set this as the directory, and then I'm going to call this as a data is equal to, and my file name is customers data. I'm going to put it as it is. Okay, the data is read into the data frame, and now what I do is that I'm going to perform k-means clustering. I want to, I'm arbitrarily chosen that I will create uh, how many 5 clusters I will arbitrarily create. I am removing the first column from the data, because the first column is customer ID. I don't want to use that for doing the clustering. So I could have done that as a separate step. So that is, and then okay. So now if I see K1, so each there are 5 clusters. Each of these 20 customers went into one of these clusters, and I will also use Okay, okay. So I can see that each one of these customers is going into one of these clusters. So what I will do is I will join this and create a new data set which combines data with K1 cluster. And then, did I do? Okay, I should have used comma there. Okay, I created data one, and all I can do is I can view data one, and now I can see. Now we can see that customer one belonged to cluster one, and so did customer 11. Then let's see, the customer 2 and customer 3 both belong to cluster 3. You can see that the cluster 3 people have a tendency to buy more of frozen items. You can see that the customer 5 and 6 are also in the same cluster. So cluster 1 people have a tendency to buy more of vegetables and stationery, right? So you can see that it has created some reasonable clusters. Cluster 4 is representing the people who have a tendency to buy more of bakery items, right? Then cluster 4 people are buying more of bakery items. And then cluster 5 people seem to be buying a lot of dairy items. So we can see that there is some method, and it has done a reasonable job, but we can see that it has not done a, it's not very easy for us because this is a 6-dimensional data. We are taking that customer's preference for buying vegetables is a separate variable and preference for buying grocery is a separate variable. So effectively we created a 6-dimensional data. And for 6-dimensional data, the visualization is almost, is simply ruled out. Though we can do a very, very limited visualization, but it is not going to be compatible like our 2-dimensional data. So now in this situation, we can see that what K-means algorithm has done seems to be a reasonable job. So now what I will do is I will stop sharing. So now let me, what we will be doing now is I will open again RStudio, and this time I will be doing hierarchical clustering. And we will take the same data that we have used in the class and plot the dendrogram using RStudio instead of plotting it manually. Okay, I'm going to close whatever is. Okay, so now let me start the hierarchical clustering. So what I have done is that I have created 6 data objects which are all taken from the slides, and what we have done is that 6 points each of 2 dimensions, and we created a distance matrix from this data frame. Okay, So now let's look at the distance matrix. It is showing only the triangular matrix because that is good enough. Now what we will do is that we will create a hierarchical clustering. What we will do is to start with this is a H cluster. You need to install the appropriate libraries. H cluster will come from the library is also H cluster. If somebody had a doubt, you can come back to me. I can post it in the Texila. If you try and okay, I am taking the distance matrix and I am calling this as method. I got HC1, which is a hierarchical clustering. I can plot this. So as we can make out, first it joined 3, 6, then 2, 5, then 4 is joined, then finally 1 is joined. So similar thing we can try out HC2, which is C2 will be the maximum is called as complete. Okay, the minimum is called as a single. So we created HC2 and then we can plot. So here 2, 5, then join with 1, 3, 6, they join with 4, finally they all join. So then if we take this is when we take the group average. Okay, so I'm stopping to share the region. Mr. Nagabhushanam, what is the question? The plot, the previous one, which one? The k-means algorithm. The k-means algorithm is a 6-dimensional data. 6-dimensional data, how do we plot? We will look at very subtle techniques which are available for some visual representation, but it will never be a satisfactory visual representation for 6-dimensional data. You can never get that. There are some techniques where you can give an indicative show of how they are related, but not for 6-dimensional data. Mr. Vivek, your question, what is that? Can we do add tree diagram? I'm still trying to understand what is that add tree diagrams with centroids. What is the parameter in R? Okay, can we do tree diagram with centroids too? Oh, okay. Whether such a visualization is available, where we have the centroids and plot tree diagram. See, the one thing that we can very easily do is to make the 2-dimensional plot. So the 2-dimensional plot is a no-brainer. So if we look at this plot, we can easily make. But then if you are saying whether the visualization is available to showcase this, is that what you are asking? Okay, after showing this, we want to see whether the clusters can be shown. I do not know. I need to explore. Maybe you can also explore. I have explored only the dendrogram plots, but whether the hierarchy, there may be some library where this is possible, but I need to check up if such a library is available. I think you want to look at like this, right? You want to have this type of a plot where you have the objects and then they are circled. Uh, I do not know. Maybe I will again. I have to explore the R libraries like you want to do, but I welcome. Right? Okay, so okay, so now what we will do is that we will start the. We will not go into great detail, but we will look at density-based clustering only to give you. This is also a partitional clustering. Most of the density-based clustering work in a partitional mode, but we do it only to indicate that it can solve some problems which k-means is unable to solve. So we will learn about the density is that it is instead of looking at the nearest neighbor, it is looking at the density connection of the points. How many neighbors are close by? So that will represent the density. So I think we were talking in the previous class about how do you know that it's a city or village. I think most likely your first impression will come from the density of the population. Am I right, or somebody thinks a different way? Because somebody has given very different kind of answers. But I thought that will be the most likely observation. You see whether in India or abroad or anywhere, the city means the first impression that you get is the density of population. So it is the density is how many what is the strength of the neighborhood within a defined neighborhood. Okay, so the advantages of density based clustering is that it can find clusters of arbitrary shape. It can handle noise very well. It can solve the problem with a single scan, and it may require some density parameters as termination condition. So there are several density-based algorithms. We will only look at one representative classical DB scan, which is relatively older density-based algorithm. So density-based algorithm requires the parameters, which is you need to consider the neighborhood. If I'm talking about whether it is city or village, I need to consider the distance within 1 square kilometer or a few hundred meters. I need to have neighbors because if there is somebody within 500 square kilometer distance, very well that may be a person living in a some other city, right? So we need to have a radius well defined, and similarly the minimum points to be defined because at least that much density has to be available. Then only we will say that this it is it is living in a dense neighborhood. So we define NNPS, so which is when n epsilon, which is that within the epsilon radius, how many points are there? For one point, the Q is in epsilon neighborhood if the distance of P to Q is less than epsilon. So we say a point P is directly density reachable from a point Q if P belongs to the epsilon neighborhood of Q. So if we consider a point as a core point, if it has a minimum number of points within its epsilon neighborhood. So we can see that minimum points is 5. So Q is a core point because there are 5 points within neighborhood. But P is not a core point because it doesn't have 5 points within its neighborhood. We define density reachability and density connectivity. Density reachability is that a point P is density reachable from a point Q if there is a chain of points such that each next point is directly density reachable from the previous point. So we are saying that we are trying to connect P is density reachable from Q. So Q is, let's say, is P1. So we are looking at P2 such that P2 is directly density reachable from P1. Then P3 is directly density reachable from P2, and so on. In that case, we say that for every Pi it satisfies, then we say that P is density reachable from Q. And there can also be a density connectivity. We say that there is one point which is density reachable from this point. Another point which is also density reachable from this point. Then we say that this point R and point S can be considered as density connected because they have a common point from which they are density reachable. So now let's look at dB scan nomenclature. dB scan depends on density within epsilon neighborhood. A point is considered core point if it has a minimum number of points within the epsilon neighborhood. It is considered a border point if it has fewer than minimum points within epsilon neighborhood, but it is a neighborhood of a core point. So in this case, P is not a core point, but P is within epsilon neighborhood of Q. So what it means that P is a border point. And you can have a noise point which is neither a core point nor a border point. If it belongs to neither of the categories, we call that as a noise point. Okay, this is the diagrammatic representation of core point, border point, and noise point. Now let's look at dB scan, which is actually a simple, elegant algorithm. So all that is doing is that first you need to compute which are the distance from each point to each other point. So that you cannot avoid. Then what you are going to do is you are computing what is a core point, and you are computing what is a noise point, and you eliminate the noise point. This is so you only deal with core points and border points. Then what it does is that it is starting with a cluster label, and it is finding out a point which is a core point, and it is assigning the cluster label to the core point and then creating a new cluster label. Now what it does is that the current core point with cluster label, and so that is for the core points. So if the core point is not having a cluster label, then it is assigning a cluster label. So next thing what you are doing is that You are checking for the core points, all the points in the epsilon neighborhood. So this is not a loop, this is only an if condition. Okay. If the point is a core point and it has no cluster label, we are assigning it a cluster label. So we are so we may have 100 core points. We start with one core point. We check that it has no cluster label. We are giving it a cluster label. Then we are looking for all the epsilon neighborhood for the core point that we have checked. We have assigned the cluster label. So then what we are doing is that if the point does not have the cluster label, then we are assigning the cluster label of the current core point. So all the points within the epsilon neighborhood are getting a cluster label. Then we are continuing with the next core point. And once we are done with entire data, then we are done, because all the core points are considered. Automatically all the border points are getting considered. Okay, so it's as simple as that. Find out, first thing you have to put effort in getting a point object as a core object, border object, or noise object. But once you do that, it is a simple, elegant algorithm. So if so, the point is, if we look at, for example, let's go to this could have been done in DB scan, though we are not going in. For example, let us say we defined that the DB scan epsilon is equal to some arbitrarily. Let us define that epsilon, we consider it as a 0.25. Okay. So then what will happen? And then let's also consider that we also consider min points. Three. Then what will happen? We will see that if you look at okay, 0.25, give me a chance to change it. Because I'm seeing the data min points. I will change it to 0.3. Okay, epsilon is 0.3 and the min points is 3. So now I start considering this. So let me look at P3. P3 is going to be a core point, right? P3 will be a core point. Let me mark the core points by green. And let's look at P2. P2 is also a core point. Let's see, P1 is not a core point, or P1 is coming out as a core point. Okay, P1 is coming as a core point. Then I need to change the parameters. I'll change the parameter. What is the big deal? So I will say that this data set was not meant for DB scan. Okay, min points is equal to 4. So 3 will be a core point, and similarly 2 will be a core point, but 1 is not a core point, but 1 can be reached from 2 or 3, so 1 is a border point. Okay, so accordingly we are getting the definitions done. And if we now, because now in this case we are not getting a noise point because point 3 we have taken, and every object is coming within the neighborhood of some object, but then some points can also come as a noise point. For example, we have a new object which is defined here, which we call that as a O7. Oh, okay, O7. P7, which is point 1 and point 02 and point 02. This will be away from every other object by more than point 3. So this is going to be noise point. It is not going to be a, within neighborhood of any object. So it is not a core point or a border point. So that is the concept of border points. So now we can see the visually how do the border points, noise points, core points look. The green ones are core points, and blue ones are border points, and red ones are noise points. So this is based on the epsilon, but depends on the scale, but you can make out visually. So DB scan is the greatness about this is that it is resistant to noise. It can handle cluster of any shape. As long as the density is preserved, it can be any shape and any size. But it is sensitive to parameters. So here we can see the examples where we are getting a very different results by changing the parameters. So the A is done here. We have done the clustering with the epsilon of 0.5. We have done epsilon of 0.4. We can see that we are getting a different cluster with different shapes for the clusters. Similarly here we are seeing different because epsilon of 5 here and epsilon of 3.5 and epsilon of 3. So what it means that unless you can choose the parameters very accurately, it's going to be a problem. And with high dimensional data, density is a very you simply cannot visualize. So then that is going to create a problem. So typically we have to go with determining epsilon and minimum points first. Generally what is done is that you plot the kth nearest neighborhood distance. So you sort the points in the order of the increasing distance. So you can plot this. So you can see that the more and more points get covered when you increase the kth nearest neighborhood distance. So accordingly, you can choose the epsilon. Yes, Mr. Vivek, it is very sensitive to small changes in epsilon, particularly when the density is highly variable. So for example, you want to take your city and you want to use an epsilon and then you want to use the neighborhood and the clustering. So obviously it becomes very different where somewhere people tend to live in independent houses and the places where people live in somewhat apartments or something. So it's the kind of density variations can be so significant that it becomes a challenge. So you need to, you don't have a choice because obviously you are depending on a parameter and you are working with a large data set. So next topic is cluster validation. So we will study this maybe in the next session. We will start this because we are almost reaching the end of the time. So I will see if anybody has any questions that I can answer now. If there are no questions, because this is a new topic, uh, we will require maybe at least half an hour to discuss this. So we'll start in the next class. So fine, I'm not seeing any question. Okay, Mr. Nagabhushan, when will be the next class? I think we have a class tomorrow, right? Tomorrow, I think as per the calendar, we have a class. We do have, and the May 3rd is the examination. Yes, we will close the syllabus in another. Right now, I require I think another 4 to 5 classes to complete everything. So we will close the syllabus well in advance. Yes, yes, sure. Okay, so conceptually, next 2 classes we will complete all the concepts, and then we will do some applications in the another 2 classes. So that should all be. That is what I'm foreseeing. So let's see. Okay, so there are no more questions. So assignment I will declare. I will announce it. So do you want the see the people? If you want the announcement assignment to be announced early, I will do that. But what people say is that we have to complete the quiz. So I will announce it in any case. I think it was meant to be started in April 15th or so. But if you want me to announce it quickly, you want to start working it, yeah, I can announce that. I'll announce that. Right? So in the next class, actually, we can discuss what is the type of assignment if somebody wants to. Okay, so there are no questions, so we'll close this session.